Okay, so I think we can begin this course. So welcome to the first Virtual Geology and Planetary Mapping Winter School. In this introduction, I will talk about geological maps, and in particular, why geological maps are important for the Earth and on other planetary bodies. Sorry. And so we should keep an eye to the recording, sorry. Sorry, a moment. Okay. So, and okay, now that we are sure that we are recorded, yes, I was saying that this introduction is dedicated to geological maps and explaining why they are important on Earth and in other planetary bodies. So a geological map is a planar representation of a territory showing composition properties and ages of rocks and deposits at the surface, and from which it is inferable its geological evolution, as well as subsurface structure and composition. To the right, you see a geological map in which you see different colors, and the different colors means different composition of the rocks and property of the rocks, but in the meantime, the meaning is also the age of their emplacement. So looking to a geological map, we also understand the geological evolution of a territory. In addition to the color, you see even symbols, and the symbols explain, are dedicated to the geological process that acted on that territory. If you cut the territory along some lines, just looking like a slice of a territory, from the geological map, you can infer the subsurface geological composition and structure. And you see underneath this geological map some geological section showing how is the subsurface of that territory on a given geological, along a given sections, along a given topographic profile. So for all these reasons, from when the geological map were produced at the first time, so in the 19th century onward, geological maps were important and essential for different purposes. The first one is science investigation. The second is resources and mining exploration. The third, resources evaluation, exploitation and management, hazard and risk assessment, land use and infrastructure planning, and finally, environment safeguard. In this map that you see to the right is the map, the first produced map by Smith in 1815. It's of Wales and England, and Smith, for the first time, understood the sequence of the different units that were emplaced one on top of each other. And so produced the first way of doing a modern geological map. And it was done for calls, for resources. So since all these points are important, a country giving up geological mapping is a country unaware of its own territory, including resources and environmental risks. This means that a country that do not have a geological mapping program has not a territory control. That's why each nation in the world and each province of that nation in the world have their own geological survey or administration dedicated to geological maps. A country without a national geological mapping program is actually a lost land. If we want to decline these points for planetary exploration, why geological maps are important on planets or for planets, we have that even on planets, we make science investigation. So research and mining exploration for planetary bodies is in situ resource exploration. So the explorations of the resources that you can find in situ in order to use them for temporary or permanent settlements. Then you have resources, evaluation, exploitation, and management. And again, in situ resources, evaluation, exploitation, and management. Hazard and risk assessment. So with geological map, you can evaluate the landing and the rerovering missions, hazard and risks. Land use and infrastructure planning. Again, even on planets, you need to plan the land use and infrastructure. And you need geological map for making these plans and for permanent or temporary settlements. And finally, environment safeguard for planets, we call it planetary protections, and it's mainly related to astrobiology. To the right, you see the geological map of Schumacher 1960, which is the first geological map ever done on a planetary body, and in this case, on the moon. Because it's essential, even for planetary body, we may have the problem that when we explore a planetary body without a geological mapping program, we are going to explore a lost land, even in the moment when we do our exploration. For these reasons, for example, USGS at the moment is producing important geological map for all the world, but no other geological surveys in the world are doing such geological mapping. For these reasons, Europe has funded two projects. One of them is PlanMap project, and the other one is GMAP infrastructure related to Aeroplanet 2024 projects. So in order to not be embarrassed when we will explore different planetary body or we want to make settlements there, we should consider geological map. The PlanMap program is aimed to use data from several missions to Mercury, the Moon, and Mars in order to generate innovative products useful for future planetary explorations. Missions that are foreseen for the exploration of Mercury, Moon, and Mars, even as orbital missions and landing or rovering missions. So the aim is to use all this data in preparation of the future missions. GMAP, in the other hand, aim is to establish a solid infrastructure to foster, support, unfortunately not economically, and sustain the production of planetary geological maps and related products on any planetary body and small body of the solar system. So if you need technical or science support in your research after the school on geological mapping, you can contact GMAP infrastructure or have a look at GMAP site. A geological map, it's not so different from a musical score. In both the the musical score and geological map, you have symbols which gain their meaning under the light of time. So with notes you can and time you can create music. With symbol of a geological map and time, you can understand the geological evolution of a territory, of a planetary body, of a world. And in the same time, anyone can listen and appreciate a good music. And anyone can see the colorful map and appreciate them of a geological map. But no anyone, or not all of them, are able to compose music. And not all the people are able to produce geological maps. In this course, we want to let you begin your first geological map. Let you learn how to compose your first geological maps. How the school will work in the next days, in next 5 days. You know, we have a basic school and an advanced one, and finally a workshop related to virtual environments. Both the basic school and the advanced one, and even the workshop, is subdivided in lectures, theoretical lectures, and practical activity. Every evening, you will receive information on the Zoom links of the activity foreseen for the day afterward. Lectures and practical activity introductions can be followed always at the same link and will be all recorded with the only exception of Moon Geological Overview and Absolute Model Ages. In any case, for these two lectures, we will provide some substitutions in terms of materials to be studied. At the end of each talk, there will be around 10 minutes for question or for you to take a rest between the talks or the practical activity, or between a talk and the practical activity. The practical activity do not envisage rests, because you may carry out your work taking your time during the practical activity. You can interact with the instructor during synchronous activity and also with other participants, and you can interact with the instructor and other participants even using the Open Planetary Forum. In some, you see the Open Planetary page here open, and there is even a tutorial on how to use it. In some practical activity, you will be subdivided into groups in different ways, so that it's more easier to you to follow the practical activities. The leading instructor of each practical activity may communicate more organizational details during the introduction and may specify material required for the certificate of attendance of that particular activity.